Hello, everybody. Welcome to week 8 problem solving session. The last week, I think there will be one more session which I will be taking, and in that session, I will be revising all the stuff and I will be solving some problems, some mathematical problems, not the theoretical. I think that session will going to held Wednesday, I think. So please do attend that session because that session you can ask questions and also I will be solving problems the mathematical problems. Like so, week 1 to week 4 are the weeks where can expect some mathematical problems. I will solve some problems in that session, but in today's session, I will solve only questions related to assignment 8. So as you have already noticed that week 8 is all about flexible links and also uh, Professor Felix have revised some topics about the controls. I mean, in that he advised how to calculate forward, how to like how we do forward kinematics, inverse kinematics, and also how we do inverse dynamics and forward dynamics. So those things, uh, those things the professor have shared in this week, right? And he also shown us like how to simulate those robotic conditions, like how to use MATLAB uh, to see how your joint is moving, right? So that is what the week is about. I mean, there is no such research part, but I think flexible link part is much more on the mathematical side. So I think you don't need to worry. So you don't need to worry about those big equations. Just need to you just need to know what are the boundary conditions and what are the governing equations they have used and how to solve this. You don't need to remember those long equations, but you do need to remember what are the different cases, what are the different modes, and like how to solve such equations. Like there's a displacement equation, right? So their displacement equation has two terms. One is the spatial term and other is the temporal term. We need to know like how they are using it and how what are the boundary condition governing equation. Don't need to remember those equations, but you do need to know how they are solving it. So yeah, so if you can skim through this assignment, you can find these like what are the mathematical approach to solve a problem. So there is so which theory has been used, when Euler, Lagrange multiplier. So this can be easily answered. Like what is the flexible mode when the beta is one. So betas are the different modes, right? And the bending moment. So here they are asked about the boundary condition. Like if the condition is pinned and like what will be the boundary condition here? Is it bending moment or displacement zero or is it the bending moment? So you need to remember this boundary condition for every case. I mean there are three cases like fixed end, pinned end, and the free end, right? You need to remember the boundary condition. I mean those are very simple things which you can remember. I think yeah. And so there is some kind of a revision which we have already gone through in the last two lectures, the model based control of robot manipulators and the simulation of so this is some kind of a revision kind of a thing. So he professor taught about the same thing which I think Professor Karana have gone through in the week 4 lecture. So it's nice to revise the thing. I mean, what are the equation? But I think the novel part of this lecture where the simulation part, like how to simulate, what are the block diagrams, like what are the control strategy, how they are implemented. So that is novel part. So yeah, so I think in this week there is only 9 questions. So I think you can easily answer this. Okay, but based on this week, I've already formulated some questions can help you in your final exam. Okay, so let's start the today's session. So yeah, coming to the first question, so what are the two generalized coordinate associated with a flexible link? This is a straightforward question. So we're talking about flexible link here. Okay. So when we are talking about flexible link, there are first we need to understand when when the links are rigid, what are the parameters which you want to know, right? There are different types of parameters are there, right? So if these are the rigid links, right? There is only one thing which you want to know, which is theta, or let's say if it's a prismatic joint, then what is the displacement? How is the displacement? These are the two variables which you want to know when it is rigid. But whenever it is a flexible link, there is always some kind of a deformation is happening due to its weight or some kind of a vibration, due to some vibration, right? So apart from theta, there's some term called delta. So not delta, but W. W is a lateral deformation caused due to its weight. Okay, so that delta is a deflection basically. Right? So so your answer here will be B here, joint angle and link deflection. Okay, not link mass. Link mass is always constant, so it's not a general. It cannot be generalized coordinate, right? Uh, so generalized coordinate is something which changes with time or like I mean which changes from joint to joint, right? Whereas mass remain constant for can for their respective link. Joint angle and link volume, no, not at all. So yeah, answer here is B. It's a straightforward question. Going to the second question. Name the three cases we have studied in the defining the boundary condition of a flexible link. It's also a very straight condition. Like, so what are the three conditions? The first condition is the pinned condition, right? If you have a link, right? So this kind of a pin joint. Yeah, so this kind of a pin joint. So what it allow is like it allows you to rotate and the pinned condition. Then other is a fixed condition where don't allow you to bend things. Yeah. Can be easily rotated. This pinned condition. Here the bending moment is zero, whereas here the bending moment is there, right? So there is some kind of a resistive movement is acting where here don't have that resistive, right? So this is a fixed condition, and the last condition is a free condition where it, the end is not been attached here. It's a free condition. So here the answer here will be B, uh, pinned, fixed, and free. So going to the third question, having obtained the joint torques as a controller output given by the question on how will you obtain the actual joint acceleration from the dynamics model control of robotics. You you know what is the dynamic model of optical system is like. It's something like I the double dot. I is the moment of inertia, the inertia component, and then there is something called E the, the dot, and then there is something the dot, right? And then there is this correlates or a centrifugal component, and there is also called a g theta, which is a gravitational component. There is one more component which is which is due to friction. This is something like b theta dot again. This is a friction component, but here it is not given, so we need to neglect this part. But you have this talk term, right? And they are asking about how will the actual joint acceleration. So what is acceleration? So this is the acceleration vector, right? So we need to calculate this. How to calculate this? We just need to take this term in the right hand side, and this is tau minus. So you won't get C inverse, right? Get something like this, and you see there is theta double dot. So theta double dot won't qualify, right? So this term looks like that, and so you get I theta double dot, and you get the RHS side tau minus something like, right. And if you do you take I to the asset, it will be I inverse, right? So in this case, they haven't mentioned what B is. So we need to take B as inertia component. So the I will be taken as B inverse, right? So they haven't mentioned, but for the simplicity, we can take B inverse is your inertia component. So here answer will be again B. So you need to understand. I mean, so that's what the motive of this full course. Need You don't need to go through the depth of the mathematics. We are not doing research here. Okay? Because if you go through the last 2 3 weeks, most of the mathematics is is not for your end exam. That's why if you see most of the assignments are theory based. Okay, but it doesn't mean that you don't understand the concept, right? So you do need to understand those equations. So those are governing equation for any links, any multiple links, right? So you need to remember this equation. So these are the governing equation, and you need to know how we will go from this to, let's say, a joint talk. Like if a tau is given, you want to calculate what is the theta and theta dot, right? So that is what we call as I think the forward dynamics, right? But tau is given, we need to calculate what is the theta double dot, or what is the kinematics, right? So you need to understand what are these equation, okay? And if possible, please do also go through those block diagrams. For those block diagrams are the building blocks for you to code stuff, ultimately build your own system, right? So is the option here. And then question number 3 is your answer. Then going to the fourth question, one of the common approaches used for flexible link kinematic modeling. So yeah, when you solve such problems in data, you can easily calculate. But thing is, for flexible link, you need to also calculate what is the deflection, right? And if you remember, Professor Felix have solved W for 4 modes, right? When beta equal to 1, beta equal to, so each mode, something like this is a mode. So this is mode 1, and if it's mode 2, then there is a small kind of a curvature is there. So whenever you increase mode, this the curvature, the bending him get more curved, right? And what kind of method we call it? Is it a supporting method or finite dealing method? So they have used a method called assumed mode method. So in that we have assumed beta to be beta equal to 4. Okay, so that we can, so beta is 4 is something like is more curved. Okay? So you can take it to beta into 8 also, but generally those kind of flexible link won't be used for robotic application. Generally we use rigid link, but rigid link also have, let's say, a metal link you are using. Metal link also has some kind of a capacity. If you are using some kind of a rubber, then link as a rubber, then their beta will be something like 8 or 10. So we are using 4 because that is the material characteristic which generally in use make up wood. So A is the right answer here. Going to the fifth question. So if you have any question, please do ask. I know there's nothing much to ask because most of these questions are comprehensive related term. But please do attend the Wednesday session. Uh, you'll get a email intimate by today or maybe tomorrow. So that will be the last session, last problem solving session, and there we will discuss more about the mathematical problem, which will help you So yeah, so we how DH parameter based forward kinematic equation be verified. So yeah, so if you have calculated to the DH parameter, right? For the DH, like you have those, right? Uh, I think there is a why is there is offset that is offset or maybe why is there the link length L is there. So if you have calculated the DH parameter and you wanted to see if your DH parameter is right or not, so they're asking like how DH parameter based forward kinematic you should be verified. Based on this DH parameter, you will calculate those right. You will calculate those transformation metrics, right? He multiply, he multiply stuff and right. So how you will verify that your DH parameter is correct? There are options. So like by checking with inverse kinematics, right? Checking with inverse kinematics. So like for DH parameter, you already know alpha, D, and L, and so forward kinematics means you know theta, and based on this F is your transformation thing, you will get X, right, which is something like Cartesian Cartesian space. So going from a joint space to Cartesian, that is what for forward kinematics. So by checking with inverse kinematics, so in order to do that, you need to know. So like if you have a robot, right? So you can't always know the X here, right? But you know theta, right? Suppose if you have a robot like this, so like each joint has a motor, right, which will moving that link, and each motor will also have a sensor. They can always tell you what is the joint angle, but they can't tell you what is the x, y, z. Okay, so you can't always uh, do an inverse kinematics. A option is wrong. Then coming to B option, by giving regular joint angular input. So how that is possible? So like if you give a joint angular inputs, let's say if you give something like a joint angular input, and what is the joint angular input? So like you differentiate this is the x dot. You give a regular joint angular inputs, joint angular input, you will get something like a Cartesian velocity. Cartesian velocity, I think you can measure, which you can do. Then coming to C option, by comparing the standard and modified DH parameter. How you can compare a standard and modified DH parameter? You already have one. So the answer here is B here, giving regular joint angular. By giving regular joint angular inputs, you can see how the joint is behaving. Right? If you given, let's say, you have, let's say, two joint, one, two, and you have a DH parameter for two, theta one and theta. You can control this joint. You give it something like a 30-degree angle, right? Like if you have given some 30 radian for link one, 30 radian to, it will move, and by like if you have given some fast input, then it will move fast. If you have given some low input, it won't move that fast, right? So by testing those, by giving the getting the feel of it, you can understand if your DH parameters are correct. By giving those anchor input, you can answer here is B. Coming to the next question. This question is based on the boundary condition. So please do remember the boundary condition. I think if you the lecture slides, you won't find those things. We There are some blank slides. Won't find anything. A flexible link. Here Professor Philip discussed about the derivation of those three cases, right? But you can see you won't find those derivation. For that, you need to go through the lecture again and you need to write it down. Those not everything, but the part where he discussed about the governing equations and also how he and what is the governing equation and what is the solution, how he calculated those constants, right? Those things you need to remember, and also the boundary condition. Here you won't find it. For that, you need to specifically go through the lecture and write it down on your notebook. Okay, those equations are essential. Okay, so please do remember this. And yeah, I think back to the question. Which one is true for free and boundary condition? Like there are three conditions which I already told you. Here they are talking about free and boundary condition. So what is free and boundary condition? So this is something like a free and boundary condition. So let's say you have a two point, right? You have a two joint. So here this fixed. You have to print this is this end is free. What kind of boundary condition you will apply here? Let's say this is equal to x equal to, and this is equal to, and they were asking like which one is true? Deflection and deflection velocity is zero. I don't think so because see here is free and can move easily. Okay, whereas if you see if this is fixed, then the deflection and deflection velocity will be zero at that point, but not that point here. So what is the boundary condition you will apply? Since this is free, there will be no shear force and bending moment, right? So when will the bending moment and shear force act on a body? When there is some kind of external force, when it is restricted, right? But when it is free, there is no such bending moment and shear force will apply to it, right? And yeah, this is what you do. But so how do you apply this boundary condition? So I think from your if you have taken solid mechanics as your one of the course, this is what the boundary this was the governing equation for a governing equation for a movement for a bend for a bending of a beam look like, right? This equation is called the bending moment equation. Okay, so you need to tell at x equal to L will be zero. Your This is a mathematical format. Okay, please do remember this. So bending moment will be zero and also shear force. Okay, so how you will calculate shear force? Just need to differentiate again. Okay, and yeah, so I shear force. So this will be also zero at x equal to 12. So there are two boundary conditions which need to be fulfilled. Okay, so here answer will be bending moment and also shear force. So answer here is B and C. To remember, there can be multiple correct answer. Okay, the assignment is not given, but it's not guaranteed that it would be same for the final exam. Okay. B and C here is the answer, and this is the mathematical format. So please do remember this one also. So instead of asking written form, they can ask you the mathematical form also. So yeah, so this is the question on governing equation. So what they are, which one of the following correctly represent the Euler-Bernoulli governing equation? The vibration that is without any external force in a beam. Okay. So this kind of equation you need to understand, like so you need to know those equations, right? So those are the governing equations. Okay, so you can't just forget those equations. So this look like an equation, I think. Okay, this look like an. But if you see, this is also like a fourth order. This is the fourth order equation, and okay, uh, plus. So not this one, this one. Both of this your governing equation, but which one you will take? So here you see the fourth order equation, whereas this one is also a fourth order, but here this EI term is inside it. And here one condition is given, it is free vibration, right? When it is free vibration, this term represent this term represent the type of forces which is being externally applied. Okay. And this is the LHS represent the characteristics of the body which is experiencing that load. Okay. So I think I will see. You can always okay, Ajmer raised his hand, I think. Ajmer, do you have any question? You can unmute yourself. You can ask the question. You raised your hand, Ajmer. So if you can also type your question if you have any. Okay, I will check after some. So you see, the LHS is what the LHS represents the how the deflection of a beam is happening, and the RHS represent the external force. Let's say if you have a link, it is something like this. It is governing define how the link will bend. This is delta W, the deflection we are talking about, and this is density and the area of cross section. And if you to dissect this term represents how the deflection is varying with respect to time, and this term is saying how the deflection varying with let's say x. So this is x actually, right? This is origin and this is x. So as you go far, the deflection will be more because the gravity start acting, and right. So this is what the governing equation show. But in the question, it is written that it is a free vibration. Okay. So whenever it is say free vibration, this fx term will be zero. It is fourth vibration, so this term will be good for fourth vibration. Okay. So let's say if this is an equation, let's say this is zero. Then if it is right or wrong, okay, and this is a fourth order equation, and it looks the same. But what about this equation? So also the same equation. I consider this as plus. Is a difference which can anybody tell me, like what is the difference between this equation and let's say if you have made the right hand side zero, A and B, what will be the difference? Can anybody tell me? I mean, you can see that not a fourth order equation. So EI is here. Okay. So when you partially differentiate this term, you need to apply some kind of a product rule, right? So like let's say if you are first you are partially differentiating with respect to x, So there are two terms. This is A term and this is B term. So you need to apply a product rule, right? So here what it says is that this EI is your E is your no, right? E is your Young's modulus. I is your moment of inertia, right? So let's say instead of a single link like this, we have some kind of a composite link. Some link. This is some link. This is link two. This is, let's say, again link. See, the dimension is changing here, and due to this dimension, let's say suppose the link, then similarly the link two. The moment of inertia changing actually, right? From x equal to, from, let's say this is 0, this is like L by 2, L by 3, and so when you partially differentiate dou by dou x di, when you differentiate this, so when you apply product rule, this term will be differentiated with respect to L, because see that with respect to x, the moment of inertia, which is I think it's other than I think pi by 16 of 4, right? The diameter is changing. So this will change actually, right? So here answer will be D, because they're also considering the change in the inertia, right? Whereas this case they have considered EI, so they have taken EI as constant. So in this case, they are assuming that the cross section and the inertia will remain same eh, throughout the throughout the link. Is not changing with respect to x. Okay, so here answer will be D, not A. If the RHS is, so I think this is the last question I wanted to share. I think there is one more question which can be asked. Like somebody can ask like what is the so what will be the assumed displacement, transverse displacement of a uniform beam should be. So like you have also, so this, you see W is a deflection. Deflection is a function of spatial coordinate, which is x here, and temporal coordinate. And if you remember, they have taken as a summation from 1 to n link, and it will be of capital W, capital W I is, this is something like x. It's a product of spatial section. It only depends on depends on the uh, beam spatial coordinate, beam's position with respect to origin, and also the temporal coordinate time. This only depends on time. Please do remember this equation too. So what we will do is like mostly what there's something called separation of variable thing which we do. So I think if you remember this, you have already uh, read in your I think max M2, the second or third. I think in the second or third semester you might have gone through this how to solve a partial differential. So you use this kind of equation, which is The method is called separation of variable. You will choose this, you will assume this equation and you will put this partial differential equation and you will get some kind of equation. And by applying the boundary condition, you will get to calculate the boundary. You will know how to calculate. I mean, so by using this displacement, assuming this displacement, and by putting it in governing equation, you will get different types of constant, and that constant can be calculated by applying boundary condition. Please do remember this equation too. Okay. Yeah, I think this is it regarding this is it for today for today's week. I think I will also take one session on this Wednesday. Join it. That I will try to solve some numerical problems so that easy for you to solve it in your final exam. Let's see if I okay any way for you. Yeah, Ramesh. You, so yeah, I think you can email me to like anywhere. Email me on this. Yeah, and I think you can also always use this and a groups. I think I can't. So I'm a TA which is handling the problem solving. But I think these who I mean they will be hope the other TAs will reply because I don't know get to solve. I'm not involved in that. You can email and okay, I think this is it this for the week 8 session. There will be one more session where I think mostly I will cover the first week, second week, and third week. So these are the basics for the robotics. This you need to be from this or from this week only you will get the most of the questions, okay, and most of the high marked most of those. So please to take this week seriously. In ANN artificial neural network also be a part of it. So please do solve enough problems. Okay. And for the books, please refer those books which Professor, if you go to the about to the course, uh, please refer this call. And if not enough, you can please go through those books and solve as much example problem as. Yeah, I think this is it. If have any, I will upload this slide today itself. I think yeah, 19, 19 is your 19 is the due date for the week assignment. Guys, please submit your assignment. Yeah, I think yeah. I think I will stop here. Yeah, I think I will stop here. We'll meet next not Wednesday.